Welcome to livetutelage.com, best e-learning portal for IIT JEE, NEET and Foundation.
Hello students, in this video I will discuss how to calculate molarity, molality and mole fraction when components in a solution are given in percentage mass by mass. Well, this is a problem given here, and problem says that a solution of glucose in water, means there is a aqueous solution, is labeled as 10% mass by mass. W represents the weight of solute or solvent, and here we have solution, and so in which the two components are there, glucose and water. Glucose is solute and so water is solvent, and it says that 10% and mass by mass. It means that glucose is going to be 10 gram out of 100. 100 gram is the total quantity of solution, and so out of 100, 90 gram, here we have water will be 90 gram, because 100 minus 10, it will give us the quantity of water. 90 gram is water and 10 gram is glucose. 90 plus 10 is equal to 100 gram is solution. This is the data we have from this information. Question says that what would be the molality and mole fraction of each component in the solution. Well, this is the first part. First we calculate molality. Molality, its symbol is small m, is equal to moles of solute, and its formula is moles of solute upon the mass of solvent in kg. Solute is glucose and its mass is 10 gram. We can convert mass of glucose into moles by using its molar mass. 10 gram is the mass of solute multiplied by molar mass of glucose is 180.16 gram per mole. It means that 1 mole of glucose has 180.16 gram. Gram will cancel out. You can divide the values. Here we have 10 is divided by 1. 10 is divided by 180.16, and the value which we get, that is 0.0556, 0.0556, and these are the moles of glucose. Well, next we have to calculate the mass of solvent in kg, in kilogram. Here we have mass of solvent, that is 90 gram, and 90 gram can be converted into kg. 90 gram and 1 kg has 1000, and gram will cancel out. We can divide these values. 90 is divided by 1000, and the value which we get, that is 0.09, hence it is in kg, hence it is solvent, water. Now we can plug in the values. Here we have the moles of solute, 0.0556. let me mention moles, and this is the mass of solvent in kg, 0.09, and it is in kg. Now we can divide these values. It will give us the molality of the solution. 0.0556 divided by 0.09, and the value which we get, that is 0.618, 0.618, and it is moles per kg. We can round up this figure. This is the molality of the solution. Now next it says that mole fraction of each component. It means that we have to calculate mole fraction of glucose and mole fraction of water, and we know that mole fraction is equal to moles of a component divided by total moles of component in the solution. So let's say if we calculate the mole fraction of glucose, then the formula will be, here we have, let me write, mole fraction is equal to, we are going to calculate mole fraction of glucose, then moles of glucose will be at the top. At the bottom we have moles of glucose plus moles of water, moles of solute plus moles of solvent. Moles of glucose we have already calculated, and we can convert mass of water into moles. Then we can apply this formula. Mass of water is 90 gram, and so let's convert it. 90 gram is the mass of water, and the molar mass of water is 18 gram per mole, means 1 mole water has 18 gram. You can divide this value, 18 5 is 90, here we get 5 moles H2O. Now we can calculate mole fraction of glucose. Mole fraction of glucose is equal to moles of glucose. Here we have moles of glucose 0.0556. 0.0556 upon moles of glucose, again 556 plus moles of waters 5. Moles will cancel out because at the top and bottom we have same unit, and that's why mole fraction does not have any unit. Is equal to, at the top we have 0.0556, and we can add these values. Here we have 0.0556 plus 5, and the value which we get 5.0556. 5.0556. Now we can divide these values. Here we have 0.0556 divided by 5.0556, and the value which we get, that is 0.011. 0.011. This is the mole fraction of glucose. In similar manner, we can calculate the mole fraction of water. Mole fraction of water, that is another component. Then moles of water will be at the top. Moles of water upon moles of glucose plus moles of water H2O. Now we plug in the values. 5 is the moles of water upon 0.0556 is the moles of glucose, and then we have again moles of water. Now we can do the calculation. Here we have that of 5, and so this value we have already calculated, 5.0556. We can divide these values. 5 is divided by 5.0556, and the value which we get, that is 0.98. It can be written as 0.99. We can round out this figure, 0.99. This is the mole fraction of water, another component. There are two components, glucose and so water in the solution, and so we got the mole fraction of each. Now in the second part, the question says that if the density of the solution is 1.2 gram per ml, what shall be the molarity of the solution? Before we apply molarity formula, we need to know the volume of the solution in liter, because molarity is equal to moles of solute upon the volume of solution. We know the mass of solution and density of the solution is also given. From this data we can calculate volume of solution. We apply the formula D is equal to M upon V, and so from this formula we get V is equal to M upon D. Let's plug in the value. Mass of solution is, total quantity of the solution is 100 gram, and the density is given 1.2 gram per ml. 1.2 gram per ml. Gram will cancel out, ml will go up. Then volume we are going to get in milliliters. Let's divide 100 by 1.2, and the value which we get, that is 83.33. 83.33, and it is in ml. Since we need the volume of solution in liters, we convert it into liters. 1 liter has 1000 ml. ml will cancel out, and it will give us the volume in liter. We can divide it by 1000, and the value which we get, that is 0.0833. 0.0833, and it is in liters. Now we can apply molarity formula. Here we have molarity is equal to, its symbol is capital M. Molarity, moles of solute, that is glucose, and so volume of solution in liters. Moles of glucose we have already calculated, that is here we have at the top, this is the moles of solute, 0.0556. Here we have 0.0556, it is in moles. And volume of solution in liters, 0.0833 and liters. We can divide these values, it will give us the concentration of solution. 0.0556 divided by 0.0833, and the value which we get, that is we can round off these figures, we can write it 0.67, and it is moles per liter. This is the concentration of solution. You can see that how I calculated the molarity, molality and mole fraction when the quantity of components in the solution is given in percentage mass by mass. Thank you.
If you like this video, please click the like button. If you have any questions or suggestions, please comment below. For more updates on IIT JEE or NEET exams, please subscribe to our channel to get a lot of updates. Support us by following us on Facebook and Twitter. To sharpen your skills, please try out our test series on livetutelage.com. Thank you so much for watching. Have a great day.